Welcome back to Preparing for Tomorrow. In today's episode, I had the opportunity to sit down with Hendrik Lawrence from stretchflow, and we talked all things complexity theory, theory of constraints, process bottlenecks, and got his ideas on some basic theories that you can use when you're thinking about bringing new technologies into your business. So, without further ado, here's my conversation with Hendrik Lawrence. To get us started then, could you give us a quick update on what you guys do and your background?
Yeah, so strangely enough, my background is in physics. I studied physics. I then did a master's in polymer science, and my first job actually was commercializing new technology that we had developed. So,
perfect.
Yeah, so it does have a relationship to the topic that we are dealing with. And then over the years, I was fortunate to do the full breadth of functions inside larger organizations. I did tech service, I did quality, I was operations director. And then right at the end of my career, I was looking for something interesting to do. And it so happened that the top person in the world in theory of constraints in mining said that he had too much work and he wanted me to come and help him.
Perfect.
And from that time, I could never go back to working in a big organization again because it was just too much fun.
Well, and you already saw the problems that were coming.
That's right, exactly. So that was excellent, and here we are today with our discussion. So, stretchflow itself, we help clients that have got issues with meeting their mandated targets. Very often, it's around productivity. Mm-hmm. And the insight that we had was that, related to theory of constraints, is that we find that most people try and improve. When they improve, they try and improve everything. Mm-hmm. And it totally overloads the managerial span of attention. Mm-hmm. There is no way that you can do well by focusing on everything. So we help our clients find those few critical levers that if they address that, they have incredible results in a very short period of time. And that's very important, that you must have those results within at most 3 months or 4 months.
You've got to get the buy-in from the people.
Otherwise, this thing just dies a very sudden death.
And expensive often as well.
Very, very expensive, and it's very bad for your future work prospects.
Well, but also businesses, and that's where I guess we had this conversation, which was funny because today I got caught in one of the classic bottlenecks here in Sydney.
That's right. That's right.
In the airport tunnel where there was an accident this morning and nowhere else to go. And when we're looking at, we had a discussion to start off with about new technologies, that particularly we're seeing in the mining sector. Yep. And I think this year is going to be a particularly big year in that space here in Australia, where we're starting to see multiple sites adopting AI. I mean, automation's been here for a long time. Yes. We're going to start to see not only autonomous trucks, but potentially some light vehicles and light drilling rigs and dozers. And there's everything else that goes with it. And I guess in that space, my thinking was always, well, that's a lot to get done.
Extreme. It's an extreme amount.
And how do these businesses do that? And
correct.
So how does that theory of constraints and how does that thinking about complexity help?
Yeah. So just before, so obviously, I mean, we have lots of articles that we've published around it, but to make it simple, there are two parts that are crucial in order to make this work. You need agility, but even more important, you need stability. Mm-hmm. And those are the two parts. So the one is in the audit system, our classical management theory tries to deal with that. And then there's the other part, the complexity part, where you cannot predict everything that's going to happen. You need to have agility with your people, your systems, your processes, your rules. Otherwise, you won't be able to handle it.
And that's a difficult concept for people to get their heads around.
Very difficult.
Because
you need both.
Even though it's simple,
you need the and.
That's
so
right.
Many big consultancies try and push the one or the other, but unfortunately, it doesn't work. You have to have both.
And the stability is the key.
It's a key. So let me start quickly. So I'll start with the theory of constraints, but I'll work it over into the agility side with complexity. Eli Goldratt, when he started off, he talked about how do you introduce a new technology? Mm-hmm. And I'm going to do it with an example of ERP systems.
Which most of us are familiar with.
Familiar with, came in the late 1990s with great potential. And it's arguable whether it delivered all of the potential that was sold at the time. Mm-hmm. And I'm going to have a discussion quickly and just show why maybe that is the case. So what Goldratt said is, they said there's 4 things that's very important when you look at a new technology. The first one is, what is the power of the new technology? What is it bringing that wasn't there before? The next question is, this technology, what is the true limitation inside your management and your production organizational system that it reduces? Then, very important, what were the rules that you had that made the old, had you managed the old constraint or the old problems that you actually thought was normal? And then the final one is, what are the new rules that you now need to have to be able to manage it? And let's take the ERP system. Just out of interest, McKinsey brought out an article a few years ago showing that from 2015 to looking back the previous decade to 2005, if you normalize productivity, there was actually a 28% drop, or 29% drop in productivity in mining across all jurisdictions. Now this is, people will say, but the mines are deeper, the ore, no. That's compensating and making
there's still a lot of shallow bodies out there as well.
Making that part of the calculation. So there's something big that happened. So let's look at ERP systems then. So what was the big problem that managers had before we had ERP systems? Well, it was really difficult to get data, because if you had to make decisions, you had to get it typically from other departments and from other areas.
And you have the old cascading reporting.
It was a big reams and reams of paper that came through with a wheelbarrow, and that most people probably didn't read then either.
We've got a digital wheelbarrow now, it's called a PowerPoint presentation.
That's where it's now. That's right. So that was what they had. So then the new technology came in, and what did it do? Suddenly you could search for all the information that you wanted. Suddenly that limitation, this is an incredible power now that's been added to you. You have information on almost anything that you would like to measure. But what were the old rules? In the old rules, because you didn't have that data, you made decisions that were best for your department. You optimized your department. So what should the new rules be? Well, the new rules should be that I shouldn't be optimizing for my department, I should be optimizing for the entire organization, because the whole is more than the sum of the parts. Now, and that's all wonderful, but let me give you an example from theory of constraints as to why this transition has not happened. So let me say, I'm going to come to you and I say, well, in my mind, I've got 6 production departments. We're going to start with preparation, then drilling, then blasting, then load and haul, and then we're going through crushing, and we're going through the processing plant. 6 units in sequence. I want to get out I want to get out 10 units per time, 10 units of production per time through the system. On average, what would you say should I size my production departments on? Now, typically what people will say is, no, it's easy. We do 10, 10, 10, on average 10. And it seems like a great idea, because in my efficiency measurements, if on average I must produce 10, and each department can on average produce 10, I'm going to have 100% efficiency. Well, it's a balanced capacity chain. What could go wrong? The problem is that if you, however, look at what the distribution is like for your production, the 10, industrial processes don't have a normal with a 12 and a 10. They probably have sometimes 12, often 10, and then from time to time 0. So if you plot for each of those departments over the time interval, each new curve, actually the instantaneous production is the lowest of all of those curves. So if you look at the end result, you'll get 5, and you can show that from modeling that you're not going to get 10, you're going to get 5. So the next morning, the production manager comes in, he says, where's my production tons? What happened? And I will say, well, it's you, and then that department went down, no, it's him. So immediately you destroy the trust and the cooperation, because everybody fights for themselves, because everything is important. Of course. Now, of course, I've got all this data. Well, clearly we should hold people accountable. So now what I do is I put in more KPIs, I measure people more aggressively, because you will be accountable. And what happens? No, this behavior just gets worse, because the system...
Optimization still is there.
The system is not capable of delivering. Yep. So here we suddenly have a lot of problems. So employee engagement goes down, and you'll see from the measurements all through Australia, it's actually horrible, and it seems it keeps on going down. Productivity is not improving. It's a crisis all around the world. But we've got these wonderful ERP systems. So now what should we do? Well, we need to create stability in the system, because this system that I just designed with firefighting and running around and not knowing from where the next hit to your department or system is going to come, that's the opposite of stability. So what we say in theory of constraints is, let's figure out where this constraint is, and let's focus all the attention on managing that constraint as well as we can. We put buffers in front so it never stops. We put space buffers behind so it never blocks any of the production. And immediately, what we tend to do is we tend to stabilize the production at a higher level. Now we're freeing up time. And in this process, we call it the productivity platform. We have maybe 4 or 5 crucial things that's visual on the wall. I've walked into war rooms where people have 60 measurements that the management team goes through every morning. Now, I'm sorry, if you've got 60 measurements, you got a data room, but you don't have a war room, because you've got no priorities. 60 priorities half of them will be opposing each other. What does that mean? That just means you've got data, you don't have information.
And that's really that challenge. Because whether it's data, correct, which is the biggest one that we're talking about.
Correct.
It's so much data.
Not all data is equal. And this is where it goes wrong. So you will see that Yves Moreau from Boston Consulting Group a few years ago came out with the issue of 6 rules to simplify or tame complexity. And he talks about complicatedness. So the more we force certainty on what's random, interdependent, and variable, and we try and force certainty and accountability onto that, the worse the results the more complicated, the more teams we need to create, the more reports we have to write, the more. So on paper, from a high up, it looks like you're controlling that situation, but down at the coalface, it's actually a disaster. That's not stability. It's totally unnecessary effort. In theory of constraints, we say most effort that you don't spend on the bottleneck is wasted. Your efforts on the bottleneck department, that you will see it in the bottom line almost immediately. Everywhere else, maybe you'll see it, probably you won't. Hopefully you'll see it. There are some necessary things that need to be done, but...
And so using that, I mean, again, that's, I'll sort of look at a larger system when you're looking at data, but this same thinking applies to any new technology.
Yes.
I mean, we've seen it, and I guess you've probably seen it, where we talk about automated fleets, or we talk about automating new processes, or adding additional, whether it's new tools that are faster, better, more accurate. And in particularly, as I said, we're talking this year, we're going to see more autonomous mines. We're going to see that in manufacturing as well. Maybe even down to the stage of last leg delivery. We're talking in 3PL nowadays.
Yeah, it's amazing technology.
Exactly, and sensors and self-driving cars and the IoT and the AI that coordinates everything. But nothing is a standalone. Nothing is an island.
Somebody said a mine that's badly designed and operated and then automated becomes an automated, badly designed and operated mine. Which
you'd hate to think that, though, but it's 100% true.
Exactly.
You could get something being very, very good at not being very good.
Correct, and that's why what Yves Moreau proposes, whether it's digitization projects, software, any kind of organizations, simplify first, then automate or digitize or whatever else that you do.
And that's applied to anything. I mean, because the other one in that space that I know we've, at our end, we've started to see, and I think mining's seeing it in exploration as well as in production management, stockpile management, is the use of drones and the use of essentially being able to create multiple layers of visibility, being able to do even stockpile surveys with drones, but same thing. How are you using that?
Exactly.
Are you now becoming, because the new technology is often the squeaky wheel, all of a sudden you've got something you've never seen before.
Exactly.
Look at this problem we've got.
Exactly.
So how do you use that?
So where ERP systems brought the first bit of data, with all these new systems, that the data is just multiplying all the time. So your problem is actually getting bigger.
That's right.
Yeah. So now let's come to the second part of the problem. So let's say digitization is a big thing everywhere in all organizations. So let's say you are now planning to become the leader in digitization in your mine environment. Traditionally, how we do projects is that we have two parts. We have a change program, and we have a project plan for what we're going to do and when we're going to do it and how we're going to do it. The problem is, unfortunately, that a project like a digitization, sometimes even automation, but definitely digitization projects, the big problem there is that you're working on something that's called a wicked problem. So Horst Rittel in the 1970s was the first one to bring the ideas of complexity. And what wicked problems are about is that you can never prove that your solution to them is good or bad, or is right or wrong. You can just prove that it's better than something else. Mm-hmm. So the issue with wicked problems is the real fundamental characteristic is that understanding the problem is the same as solving it. Mm. So the issue is really
getting everyone on the same page.
Do we understand the problem? Do we understand? And I'll give you some details of what IT managers typically and managers of departments complain with these projects. The one would be, what information do we already have? What is the crucial information that people need to do a really great job? Mm-hmm. And if we do these implementations, how will we change the nature of this process of flow of information and what's important and what's not? So it's not a static problem that easily gives itself over to the classical way of managing projects. And that's why you see the number of failures that you do see.
With technology, and I think that's one of the big parts.
That's right.
You know, it's easy to see the technologies, to see the first stage of.
So there's constant agility and adjustment that's required. But how do you do it with a big project plan, with a department that's out there that comes in and pisses off every senior manager because they don't have time?
That's right.
Every person that now is in on this. So if you try and
fighting for that attention too.
Everyone is fighting for attention. They don't have the time. The results, if it doesn't come very quickly, they will start paying lip service, and that's the end of your program.
Well, I certainly got a lot out of that conversation, and I hope you did too. The key takeaways for me were really about looking at those two concepts around stability and agility, and how we use those two concepts in bringing together a project team, and what they mean for our approach to developing solutions, whether it's technology, hardware or software. Also, I thought the concept of the wicked problem was a really interesting one. I mean, we've all been part of teams where we've seen that we spend a lot of time just trying to get everyone to understand all the constraints, what we're trying to achieve, before we actually get into creating any solutions. So, as Hendrik said, if you can explain the problem to everyone and everyone understands it, you've potentially got the problem almost all solved. So, if you'd like any more information out of anything from today's episode, please get in touch. I've also put Hendrik Lauren's details there. Please feel free to get in touch with him as well. Thanks very much for your time. We look forward to catching you next time.